Okay, so we were talking about reversible reaction, right? And I have told you that what is reversible reaction is. Okay, so what is reversible reaction? A type of reaction in which we have reactants, like if we have hydrogen and nitrogen, so they combine together and form ammonia. This is forward reaction. Okay, this is forward reaction. Then same, this ammonia will break down and form reactants. This is backward reaction. So we have two types of reactions in this kind of reactions. This is a reversible reaction kind, and in this reaction we have two different reactions. One is forward and one is backward. The same reaction. The one is going to produce product, and then the product will be going to decompose again back to the reactants. Okay? Then you have to remember this, that the first one is exothermic reaction and the backward in this reaction is endothermic. I'm just talking about this reaction, the formation of ammonia gas. Okay, in this reaction the forward one is exothermic and the backward one is endothermic. Okay, and then we talk about dynamic equilibrium. We just talk about dynamic equilibrium. And so what is dynamic equilibrium? You have to remember this. Dynamic equilibrium is actually a balanced in this reaction. We know that in the physics that a balance is called equilibrium. So same as the meaning of equilibrium over here as well. So the meaning of equilibrium is balance. So when both the reactions become balanced. For example, when we have reactant and product, when we have these two in balance condition, for example, in after the reaction it will be 50% and it will be 50%. It is the balance of reaction, and it is happen when the rate of forward reaction become equal to rate of backward reaction. It will only happen when the rate of forward reaction become equal to rate of backward reaction. I have told you that initially when you add, like for example, if we are moving towards just like this, we have a beaker. Okay, and in this beaker we just add what? Nitrogen, and we add hydrogen in it as well, and we just close this. Okay, we remember this, a closed container or chamber is used for the reaction of this kind. Okay, reversible reaction is always carried out in closed chamber, so not any gas will be emit out or the equilibrium will be disturbed otherwise. Okay, so initially we just have reactants, so we don't have products, so definitely we don't have backward reaction, that is the decomposition of product. Okay, so initially happen what? It is just a reaction of reactants, and reactants combine together and form product. That is a forward reaction. So initially you will see that a forward reaction is going on and it's happening over here. So we just have this one. But slowly, by and by, we will see that product concentration start increasing and reactant concentration is decreasing. So the reaction from backward side starts. Okay, but it is slow in the beginning, so it is going to happen till 50 percentage. Okay, once the 50% reactant consumed and 50% product is produced, so that means now at this stage the rate of forward reaction become equal to the rate of backward reaction, because both have same concentration in this container right now. So what is this? It is actually balanced, it is dynamic equilibrium. Okay, and definitely we have ammonia gas as well in it. So when these three things are together in a same container, it is a closed chamber, so we will call them as a mixture, or we can call it as a reaction mixture. Okay, this is a reaction mixture. Then we are moving towards some factors that can affect the productivity, some factors that can affect the productivity, that can affect yield of reversible reaction. For example, I'm just giving you again the same example of ammonia. hydrogen is reacting with nitrogen and it is forming what? Ammonia. And I have told you that it is a mole ratio 3, 1, 2. It is a mole ratio. And since all these reactants and products are what? They are gases. So definitely they have same volume ratio as well. So it will be 3 centimeter cube, it will be 1 centimeter cube, and it will be 2 centimeter cube. So if we double it, so it will be like, or if we increase it by 100 times, so it will be 300 centimeter cube, 100 centimeter cube, and 200 centimeter cube. It means that if we react 300 centimeter cube hydrogen with 100 centimeter cube nitrogen, it definitely produces 200 centimeter cube ammonia. But what happened at the end? We will see that 100 centimeter cube of ammonia is produced. Why this happened? Because we know that it is a reversible reaction. So at dynamic state, dynamic equilibrium, what happened? 50% will be reactant and 50% will be product over there. So that is why the yield is 50%. So if we are going to produce any industry in which we are producing like ammonia, which is one of the product of reversible reaction, so we require high product to ensure that all the orders of our clients will be confirmed and all fulfilled our promises and commitments. So we required more products. So what is the first thing that we can do for increase the product is increment in the concentration. Increment of concentration to increase our product. The first thing that we can do, if we using 300, we can use 600 for this. If we are using 100, so we can use 200 over here. So for this, if it can produce 400 and half of it will be 200 then. Okay, so initially when we were using 300, so we will get a product of 100 centimeter cube. But right now, if we double the concentration, so our product will be double. You can see over here. So the simplest way to increase the productivity is increase the reactant. If we again double it, if for example I just make it 1200 and 400, so definitely it becomes 400 centimeter cube. So the easiest way to increase your product is increased the concentration of reactant. Okay, and one more thing that you can do in this is the removal of product. For example, if you have if you have 1200 centimeter cube hydrogen and you have 400 centimeter cube nitrogen, and you will produce 800 centimeter cube ammonia for this, definitely it will be half consumed, and it will be half produced because at dynamic equilibrium. So you can take it out, you can withdraw it, once you withdraw it, that means you disrupt the equilibrium. Definitely the reaction will move towards left hand side. That means we just disturb the reaction. So these two start reacting again, and then forward reaction proceed. So then they start reacting and they consume half of it and then half of it, and we will produce half of it as well, which is the 200 centimeter cube. So again, if you withdraw the product, so that means you disturb the equilibrium, you disturb the dynamic equilibrium. When you emit out all the products, so definitely there is no backward reaction. So once you disturb the backward reaction, that means you disturb the equilibrium, that means the forward reaction proceeds. Again, reactants start making reactions together, and then they start proceeding towards product side. That means forward reaction proceed. That is the simplest method to increase your productivity. That is one of the factor. Okay, and the factor is just concentration. What you have to do, you just have to increase the concentration of reactants, or either you can withdraw the product. Okay, then second one is temperature. Second one is temperature. Actually, temperature depend on two factors. Number one factor is what? Number one factor is exothermic reaction, and number two is endothermic. So it is all depend on this, that which type of reaction you have. Definitely, if you have exothermic reaction, you know that heat release in this reaction, right? And if you have endothermic reaction, so you know that heat absorbed in this reaction. This is what we have. Okay, so if the heat is already releasing, so we don't need to give heat. Okay, you just take the temperature low. If the temperature will be low, that means product will be higher. Okay, in the reversible reaction, if you want to increase your product, and if you have exothermic reaction, so you have to keep temperature low. And it is reverse for this one. If you have endothermic reaction, so definitely they absorb heat to carry on the reaction, so you have to take temperature higher to high your product. Okay, it is why it is just like if I just write a very basic reaction for exothermic reaction, we know that reactants produce product and heat as well. Okay, so if we take like a balance over
Sir,
T.
सर जो डिकम्पोजिशन वाला पार्ट होता है, जो बैकवर्ड रिएक्शन होता है, इट इज एक्चुअली एंडोथर्मिक. So if we will make conditions favorable for the endothermic reaction, so there will be more decomposition and the product will decrease.
Exactly, you are right, but I am just listen to me. What I am trying to say right now, you are fine. Okay, that decomposition is the part of endothermic reaction, but in a single reaction, both things occur. Okay, there is a decomposition of product as well, and there is a composition of product as well. Okay, and if you are just taking single reaction, just see over here. For example, if you have hydrogen. Uh, okay, listen. If you have hydrogen only, okay, so what happened? हाइड्रोजन के जो बॉन्ड हैं वो ब्रेक डाउन हो रहे हैं, एंड देन नाइट्रोजन के जो बॉन्ड हो रहे हैं वो भी ब्रेक डाउन हो रहे हैं. उसके बाद आपके पास अमोनिया बन रही है, ऐसी है ना. तो अगर हम सिर्फ फॉरवर्ड रिएक्शन भी लेते हैं तो इसके अंदर भी एंडोथर्मिक और एक्सोथर्मिक शामिल होता है. ठीक है, ठीक है. तो हाँ,
Yes, sir.
तो इसके अंदर भी एंडोथर्मिक और एक्सोथर्मिक शामिल होता है. एंड इन अ सिंगल रिएक्शन यू हैव बोथ एंडोथर्मिक एंड एक्सोथर्मिक, बट इट इज डिपेंड ऑन व्हाट द ओवरऑल रिएक्शन इज. द ओवरऑल रिएक्शन इज when the bond breaking is actually what? Endothermic. When bond breaking energy is higher, that means the overall reaction is endothermic. If the bond making energy which is going to release after the reaction is higher, then the overall reaction is exothermic. A single reaction contains exothermic and endothermic, both of the type of reactions, but the thing is the overall reaction is depend on the higher energy which is releasing or absorbing during the reaction. Okay, so
Okay.
for example, if you are talking about endothermic or exothermic, both the reactions are endothermic and exothermic, both contain endothermic and exothermic parts, but it is all depend on what's happening over there. If energy absorbed is greater, then that means the overall reaction is endothermic. If the energy release is greater than the energy absorbed, that means the overall reaction is exothermic. I'm just telling you that, for example, if you just have a part like this, we know that it is exothermic part now, in when reactants produce product and heat energy. So you can see that it is a product and it is a reactant. So dynamic equilibrium settled between product and reactant, and one of the product is energy as well. If you increase temperature over here, that means you are increasing product. If you increase product, that means the reaction will move towards reactant side. Is that right?
Yes.
Dynamic equilibrium will be established now, and it is always happen when both have 50% like shares. If you increase a little share of anyone, so the reaction will be moved towards the opposite side. So if you increase temperature in exothermic reaction, so that means you are increasing product actually. So if you increase product, that means the reaction will move towards reactant side. That means it is a loss of product. And it is, if you see over here, so we know that reactants absorb heat energy and it is forming product, right? It is for endothermics, and for example it is a balance. So if you increase heat energy over here, If you increase heat energy over here, that means you are increasing reactants. That means you are increasing reactants, so it will move towards product side. So it is favorable for the product. If you increase temperature in the endothermic reaction, so it is favorable for you. It will increase the productivity of the reaction. Got it?
Yes.
Okay, so we are moving towards the next factor, which is pressure. Okay, so the next factor is pressure. So if we talk about pressure, so favorable for it is only favorable for gases. Just remember this. It is only favorable for gases. So like we have 3H2 plus N2 gives you ammonia, right? So it is gas, and it is gas. So application of pressure can be possible over here because all the products are gases, or all the reactants are as well as gases. So we can apply pressure over here. What is the application of pressure? We remember the thing for this. When you apply pressure, when you apply pressure, the reaction will move towards less number of moles. Reaction will move towards less number of moles. Just remember this. If you apply pressure, it is only work for gases. And if you apply pressure, so we remember the reaction will move towards less number of moles. So over here, you can see just like if you talk about a reactant side, so you can see over here that we have 3 and 1. We have 4 moles over here, right? And over here, how many moles? We have 2 moles. So at which position we have less number of moles? We have 2 moles at product side. So if we apply pressure in this reaction, so what happens? We will increase product, right? So if we apply pressure in this, it is favorable for us that it will increase our product. So definitely we are everyone working for his own bread and butter. So definitely everyone wants that the more product will be formed and the more profit will be formed, so they can earn more amount. So we want to produce product. So definitely we can apply pressure over here. We can apply more pressure and we can produce more product. Okay, same as if for example we have this equation 2SO2 plus O2 gives you 2SO3. So you can see over here that we have 2 plus 1. We have 3 moles over here and we have 2 moles over here. If you want to increase the product of SO3, so we can apply pressure over here. It will cost to increase your product because they have less number of moles at the product side. And one more example, if you see over here that the reaction of this kind, they all are gases. So you can see over that 1 mole over here, 1 mole over here, and 2 moles over here. That means 2 moles over here and 2 moles over here. There is no net change in the number of moles. That means there is no use of application of pressure. If you apply pressure in this reaction, that is just a useless thing that you are doing. Okay.
Yes, sir.
And the last thing that you can do for this is catalyst. Catalyst what? Catalyst is used to speed up the reaction. So simple. If you increase the amount of catalyst, or if you want to increase the amount of product, you just need to use catalyst. It will increase the speed of reaction. Definitely it will not consume, it will not increase your cost, because it is one time investment. It will be withdraw after the reaction. So if you use catalyst, so definitely it will increase the productivity, so it will save your time. So according to industries, it is quite important that they save over time and they save cost. So initially if you use catalyst, so it speed up the reaction, so it save your time. So it is very important for the industries. These are the 4 factors that you have to remember for reversible reaction. And they are the same factor that you have to remember for rate of reactions as well. Okay, girls?
Yes, sir. Yes.
Mm.
Girls, can you hear me? Can you hear me, beta?
Yes, sir.
ओके। अब देखें, ये सारी चीज़ें जो थी वो हमने कर ली बात। अब हम देखते हैं एक नई चीज़। ये सारी बातें जो थी ये हमने कर ली हैं। अब ये देखो, अमोनिया क्या है? अमोनिया इज एक्चुअली गैस यूज टू मेक फर्टिलाइजर्स एंड एक्सप्लोजिव्स। हैबर प्रोसेस से बनती है ये, सही है। ये जो हमने किया ये हैबर प्रोसेस है। मैनी केमिकल्स लाइक रिएक्शन प्रोसीड लाइक इट इज रिवर्सिबल रिएक्शन। आई हैव टोल्ड यू ऑल अबाउट दिस एंड दिस इज रिएक्शन। आपको ये बात याद रखनी है कि नाइट्रोजन और हाइड्रोजन 1:3 के रेशियो में मिलते हैं। नाइट्रोजन का 1 मॉलिक्यूल और हाइड्रोजन के 3 मॉलिक्यूल्स मिलते हैं, तो 2 मॉलिक्यूल्स आपके पास अमोनिया के बनते हैं। इट इज द रिलेशन बिटवीन दैम 1:3। ओके, एंड देन वन मोर थिंग दैट यू हैव टू रिमेंबर कि जो नाइट्रोजन है ना, इस रिएक्शन में जो नाइट्रोजन आ रही है वो आ रही है हमारे पास फ्रैक्शनल डिस्टिलेशन ऑफ एयर से। ये आपको याद रखना है, फ्रैक्शनल डिस्टिलेशन ऑफ एयर से आप नाइट्रोजन लेके आ रहे हैं, और हाइड्रोजन जो आप लेके आ रहे हैं वो आप लेके आ रहे हैं क्रैकिंग ऑफ हाइड्रोकार्बन से। तो इन दोनों के रिसोर्सेज आपको बताना चाहिए, ये एमसीक्यूज में काम आएगा। ठीक है, नाइट्रोजन इज रिसीव्ड बाय द फ्रैक्शनल डिस्टिलेशन ऑफ एयर एंड हाइड्रोजन इज रिसीव्ड बाय द क्रैकिंग ऑफ हाइड्रोकार्बन। गॉट इट? गॉट इट गर्ल्स?
Yes, sir.
Okay, then you can see over here that is a reaction. It is one of the forward reaction and one is backward reaction. I have told you raw material. मैंने आपको बता दिया, it is nitrogen extracted from air by fractional distillation, and then hydrogen is received by cracking of petroleum or hydrocarbon. ठीक है, और इसके अंदर हम जो है हैबर प्रोसेस है, तो इसके अंदर हम आयरन एज अ कैटलिस्ट यूज करते हैं। एज यू नो दैट वी विल टॉक अबाउट इट, we had talked about it in transition metals and in previous rate of reaction as well। हम आयरन यूज करते हैं। हम अमोनिया फॉर्म में रिवर्ट बैक टू द नाइट्रोजन एंड हाइड्रोजन, ये मैं आपको बता चुका हूँ। तो अगर आप इंक्रीज करना चाहें प्रोडक्ट तो आप देख सकते हैं इस ग्राफ को। देखें इस ग्राफ के अंदर क्या हो रहा है, आपका प्रेशर इंक्रीज हो रहा है एंड टेम्परेचर इंक्रीज हो रहा है। तो अगर आप देखें कि जो आपके पास 450 डिग्री सेंटीग्रेड है उस पर आपकी प्रोडक्ट सबसे ज़्यादा है। ठीक है, 400 एटमॉस्फेयर और 450 डिग्री सेंटीग्रेड टेम्परेचर, इस पे आपकी प्रोडक्ट सबसे ज़्यादा है। एज आई हैव टोल्ड यू दैट आपके पास ये एक्सोथर्मिक रिएक्शन है, तो अगर आप जो है टेम्परेचर कम करते हैं तो रिएक्शन खुद ब खुद ज़्यादा होगा फॉरवर्ड रिएक्शन का। ठीक है, और अगर आप प्रेशर इंक्रीज करते हैं तो डेफिनेटली नंबर ऑफ मोल्स प्रोडक्ट की तरफ कम है, तो ये खुद ब खुद प्रोडक्ट की तरफ जाएगा रिएक्शन। तो दैट इज़ वाई जब आप प्रेशर अप्लाई करते हैं ज़्यादा से ज़्यादा और टेम्परेचर कम से कम आप करते हैं तो आपकी प्रोडक्ट हाईएस्ट होती है इस तरह के रिएक्शन से। At lower temperature, ammonia is yield higher. You can see over here the difference between these two. One is 50 and one is 20. And then at higher pressure, you can see that अगर आप प्रेशर के हिसाब से देखें तो प्रेशर के हिसाब से भी आपके पास 100 पे और 400 पे ईल्ड का इतना ही फर्क है, 50 to 20। ठीक है, कैटलिस्ट आपके पास इसमें आयरन यूज हो रहा है। टेम्परेचर आप टेम्परेचर यूज करें 450 डिग्री सेंटीग्रेड और प्रेशर आप 250 यूज करते हैं जस्ट टू सेव योर कॉस्ट। और ये एक प्रोसेस है जिसके थ्रू आपके पास जो है अमोनिया बनती है। कंप्रेसर के अंदर दोनों गैसेस कंप्रेस की जाती हैं। कंप्रेस मतलब दबाई जाती हैं, उसको दबाने के बाद इसको आगे जो है ट्रांसफ़र किया जाता है। ट्रांसफ़र होने के बाद वहाँ से ये कैटलिस्ट कि आप देख सकते हैं ये सेकंड वाले कन्वर्टर के अंदर वहाँ टेम्परेचर भी दिया जा रहा है, वहाँ प्रेशर भी दिया जा रहा है, वहाँ कैटलिस्ट भी दिया जा रहा है, जहाँ पर ये दोनों आपस में रिएक्ट होते हैं और रिएक्ट होने के बाद ये क्या होते हैं भाई, ये अमोनिया गैस बनाते हैं। ठीक है, अब अमोनिया गैस जाहिर सी बात है वहाँ से कंडेंस होकर नीचे रिसीव हो रहा है, और जो रिसीव हो जाता है अमोनिया गैस वो जो है हम सेपरेट आउट कर लेते हैं, और बाकी जो हाइड्रोजन और नाइट्रोजन होता है दोबारा से रिवर्ट बैक होके जो है उसी कन्वर्टर में जाता है, मिक्स होता है और दोबारा प्रोडक्ट बनाता है। ठीक है, दैट इज़ ऑल अबाउट अमोनिया प्रोडक्शन। ये इस तरह प्रोडक्शन होती है। अब ये रिएक्शन आप पढ़ चुके हैं बेसिस के अंदर कि अमोनियम क्लोराइड्स के जो सॉल्ट्स होते हैं वो बेसिस के साथ मिलकर अमोनिया बनाते हैं। तो इट इज़ वन ऑफ द फैक्टर दैट अमोनिया किस तरह बन सकती है। तो यू नो दैट अमोनियम हाइड्रोक्साइड या अमोनियम सॉल्ट कोई सा भी, अमोनियम सल्फेट हो, अमोनियम क्लोराइड हो, अमोनियम फॉस्फेट हो, ये किसी भी बेस के साथ मिलेगा तो सॉल्ट अमोनिया और वाटर ही बनेगा। ये बात आपको पता है। ठीक है बच्चों, इज दैट क्लियर?
Yes, sir.
Any queries about it?
No.
So I will share this PPT with all of you in classroom. So if you want to make notes for this, so you can. Okay.
Okay, sir.
Okay,
Thanks.
sir.
That's all about today's class. We will discuss more about it later on in tomorrow class. Okay.
Okay, sir.
Take care of yourself. Stay safe. Stay blessed. Allah Hafiz.
Last.